to start with number 1 on the bottom second of the back of the orange sheet in the net force. And remember, if it's a vertical problem, you're going to need to include the weight. And so the hints that I had to get you guys started in the right direction, before you come for help, before you think you're stuck, you're going to need a free body diagram. If it's a vertical problem, you're going to need the weight. And unless it's in equilibrium, then you're going to need the mass, and that is most often. And then sum the forces and set them equal to m times a, the steps that we're doing for each one of these. Alright, so number 1, determine the acceleration that a force of 25 Newton gives to a 4 kilogram mass sliding on a surface that provides 5 newtons of frictional force. This is a horizontal problem, and it's sitting on the ground, so that's why I draw the ground here. It doesn't matter the direction, I just like the motion to generally go to the right. So I have 25 Newton applied force, and then the force of friction always opposes the motion, and that's given to me as 5 newtons. I also know that the mass is 4 kilograms, and I'm trying to figure out what the acceleration is. It's not a vertical problem, so I don't need the weight. Sum of forces equals MA. In this case, I only have 2, so on the left-hand side of the equation, I have an FA that's positive minus a force of friction. That's because it's going backwards, traditional coordinate system, equals m times a. And then plug in your numbers. 25 minus 5 equals 4 times a. 20 equals 4 times a. And 20 is your net force. Remember, either half of this equation would give you your net force. You can either sum the forces or do m times a. And then acceleration is 5 meters per second squared. Not too bad.